Hello friend, hello student, you're welcome to our lesson for today. Today we have another lesson in our advanced level chemistry practical. Our topic today we learn the thermochemistry. You know the thermochemistry. The main concept here, we are going to look the heat change. The heat change in reaction. The heat change in reaction. That is the concept of thermochemistry. When you are going to dissolve the solute or reactants, when they react, they give the heat either to the surrounding or is given out, or some heat absorbed and some reactions, the heat released out or is given out. So that is thermochemistry. And our reaction, how we are going to deal with, the first we have exothermic reaction. Exothermic reaction. And then the second we have endothermic. So when we deal with the endothermic reaction, the first here, exo. So now we are going, this is introduction. So this is introduction to our practical. So be together in order to understand later when we are going to introduce the full practicals, how can you understand them. Exothermic reaction, it means we say that exothermic, we say is a reaction in which heat is being released to the surrounding. It means the heat released to the surrounding. It means the reaction lose heat, but the system gain heat. That is exothermic reaction. For example, when you mix, let's say you have a beaker. This is a beaker. You mix, let's say, sodium hydroxide, and then you mix it with the water. It means water, there is a certain volume. It means there is an initial temperature here. Let's say you can say there is 20. Was it 20 Celsius? There is a thermometer here. And the final is, let's say it's 28. You see, it means 28, 20. In the reaction after dissolving sodium hydroxide, there is a release of heat. This means temperature change will be 28 minus 20, or T2 minus T1 is equal to this one. So the difference will be 8. This is positive. So it means the heat released out. That is exothermic reaction. You understand, yeah? So apart from this, let's describe about what is endothermic reaction. During the endothermic reaction, we say the heat on exothermic reaction, we have said the reaction lose heat. But now endothermic, the reaction gain heat. It means the heat will be absorbed to the reaction. It means from the surrounding to the reaction. So there is absorption of heat. So let's say you have observed this is your beaker. This is water. And the record, this is thermometer. means the initial temperature was T1, let's say it was 20. Yes, was 20. And then you put, let's say this one, acetic acid. What do you expect? It means our final temperature will be this one. T2 will be, let's say, there is a lower, it means will be 20, will be 14. When you find the heat change here, it means T1. Heat change will be T2 minus T1. Almost will be T2 is 14 minus 20. Almost will be negative 6. You see? That is our endothermic reaction. So we are going to deal with those reactions which involve endothermic and exothermic reaction. And our formula general for thermochemistry, our general formula will have this one. Of change in heat is equal to negative density times volume, specific capacity, change in heat. So this change in heat in this one, that is a formula. You can be given a mass, so it means O is equal to density is equal to mass over volume. Density is equal to mass over volume. So it means you can substitute this one to get mass. So change in heat can be instead of this one, you can put mass will be negative. This is lattice M mass specific capacity of water, change in heat. So those are applied. It means when you are going to use this one to find the mass, remember to use the volume of, or the formula of density. Then the density of the solution is equal to the same with the density of water, which is 1. Density of water is equal to 1 gram of volume of water. That is the volume of the density of water. So that is our formula, and that is our reaction types. And let us go another section to understand more about the thermochemistry practical. This is introduction to practicals. Okay, let's proceed. So types of these practicals or thermochemistry practicals we are going to deal with type C practicals in thermochemistry. The first we are going to study the practicals deal with heat of formation. Heat of neutralization. We're going to deal with heat of neutralization. It means we're going to take base and acid, make a neutralization reaction. There is a heat change. And then we are going to see the experiment. The second, we have heat formation. Heat formation heat formation of a compound. Let's say magnesium carbonate, sodium hydroxide. How is it formed? It means there is thermochemistry, or there is heat change during formation of that compound. Number 3, we are going to study heat of solution. Heat of solution. Heat of the solution. Heat of the solution during dissolution. Dissolution, or when you are going to dissolve the solution, there is a heat change. That is the concept for our practicals. Heat of neutralization, you can see for this one. You can see this one, sodium hydroxide plus HCl hydrochloric acid. Then we got the product and the heat change. The second, we are going to study acetic acid with sodium hydroxide. Then you will see the heat change. This is performed in one practicals by applying the 2 procedures. Do you see? So that is the first. It means for this one, number 2, let's say there is magnesium carbonate, magnesium metal, and HCl. And there is magnesium carbonate and HCl. Within this one, HCl, there is a reverse reactions and so and so. So we will see also the practical which deal with these reactors. And the heat of the solution, this one is only dissolving. And this one will deal with, we are going to see hydrated. We are going to see hydrated salt and anhydrous salt. It means, let's say sodium carbonate, hydrated, or decahydrate, and sodium carbonate, which is anhydrous. When you're going to dissolve this one and this one, there is a heat change which is different, and they will see the practical of this, or the experiment. So this was the introduction. I think you have understood this one. Another time we are going to start our practicals. We can start among of them. We are not going in series. We can start with this one, with this, and this one, or you can start with this one. There is no need of series. So it depends the practicals and the material we have at a time. So thank you for learning this thermochemistry introduction. Welcome to our practical.